What's up, guys? In this video, let's do another edition of Pre-Calculus Essentials, where I'm going to go over a problem that if you're taking pre-calculus or you've already taken pre-calculus, you better know how to do. And we're going to do another factoring example, but we're not going to do like a nice little trinomial or a polynomial to a higher order. We're going to do something with some fractional powers. And I know you just love fractional powers. But what I'm going to do is I'm going to break down what exactly you need to know. So if you look at this problem, you're like, oh my God, there's no way I'm going to be able to do this. Or I know how to factor, but once you give me fractions or you give me negative powers, this is just making everything more confusing. I'm going to break down the fundamentals that you absolutely need to know. So therefore, when you see a problem like this on your test, you can take a nice breather and say, okay, let's focus on what I know, and then let's start applying those. And that's what I tell my students all the time. You're going to get problems that you get confused on a test or a quiz or on your homework. That's okay. That's a part of the learning process, right? But what you need to do is take a breath, stop, and say, all right, what is it that I know? And then how can I apply things? Okay. So the first thing is like, all right, we're doing factoring. I have two terms, right? When you think about factoring with two terms, you think of like difference of two squares, sum or difference of two cubes, or think about factoring the GCF. I don't see a difference here, and factoring two cubes with rational powers, I have no idea. So I'm going to think about factoring out the GCF. Now, I do recognize that these two terms are exactly the same. So that's why I'm like, all right, I can probably factor out the GCF. But let's do a quick review of factoring out the GCF just to make sure we're kind of understanding exactly what we're doing. So what if I had a 3 x squared plus a 5 x cubed? Okay, so if I needed to factor out the GCF, I know I need to look for what they have in common. And you can say that, hey, they both have an x in common. But I just don't want to factor out an x, right? We're looking for the greatest common factor. So I want to know x raised to what power is the highest that evenly divides into this 3x squared as well as this 5x cubed. Now that answer is going to be an x squared, right? Because x squared divides an x squared one time, and x squared divides an x cubed x times, okay? So when we factor out that term, basically what we're doing is dividing out that term from each of those. So what we're going to do is rewrite this expression, that is what factoring is, as a product. So it's going to be x squared times what's left over once I divided it, which in this case is going to be a 3 plus a 5x. Now, just remember, ladies and gentlemen, we can always check our answer of factoring. Even if we're like, I'm not sure if I did that right, go back and multiply it out. And you can do this in your head. You don't need to write it out. X squared times 3 is going to 3x squared. X squared times a 5x is going to be a 5x cubed, right? So we're like, all right, I got that. I remember how to factor. The next thing is I see exponents, and I see, even worse, fractions or negative fractions. But let's come back to that in a second, okay? Let's just focus on some exponents. So the one thing we need to understand, if I'm going to factor this out, not only do I have to have the base be exactly the same like x, but I also have the same power to be exactly the same. Because one thing that, a little caveat here, you could rewrite this as a 3x squared plus a 5x squared times x, right? Because wouldn't you guys agree that x squared times x to the first power is x cubed? Now, how did we do this? Well, that comes into the rules of exponents, right? So I can break up this x cubed into x squared times x, because remember, when you multiply exponents, you add the powers. So let's do a quick little review of that. So if I had x to the m times a x to the n, that is going to equal an x to the m plus n. But here's where things get special. And a lot of times I don't think we spend enough time in our schools going over this with students, because some students are going to get it like this, but then some students really have a hard time going from a rule in this direction, but then also understanding I can take this rule and go in the other direction. If I have an exponent raised to two powers that are being added, I can break that up into an x times n times an x times n, right? So it's really important. The rule works both ways. So what I need to be able to do is I have a negative 3/4 and I have a positive 1/4. I need to get those numbers to be exactly the same, because if I can get those numbers to be exactly the same like I did over here, now again, for these simple ones, a lot of times we just do it in our head. We don't think about breaking this up. But when you have something with like fractions, it's a little bit more difficult to think in your head what would be that common power that you could factor out. So what I'm going to do is then say, all right, let's pick one and say, how can I rewrite this with the other, with that other power? So if I have a negative 3/4 and I have a 1/4, how can I maybe rewrite 1/4 with a negative 3/4? Well, you can think about if you were to add a 3/4, that'd give you 4/4, which would give you 1. So here's what I'm coming up with. If I rewrite this as an x times x plus 1 raised to the negative 3/4, and then over here, what I'm going to do is I'm going to rewrite this as a multiplication statement. I'm going to say an x plus 1 to the 1/4, I'm sorry, not to the 1/4, to the 4/4, and then I'm going to multiply that times a x plus 1 to the negative 3/4. Now we know 4/4 is 1, right? But again, look what happens, guys. What would happen if I were to multiply these in, what am I thinking of? Just by themselves. If I did x plus 1 times 4/4 times a x plus 1 times a negative 3/4, what would you do? What would the rules of exponents tell you to do? The powers are exactly the same. I know it's an expression, but the base is exactly the same. So therefore, this is going to be an x plus 1 times a 4/4 plus a negative 3/4, right? That's what the rules of exponents tell you. And what does that give you? That gives you an x plus 1 to the positive 1/4. So in reality, I'm not changing this problem. I'm keeping it exactly the same, right? All I'm doing is I'm breaking it up using the rules of exponents. But now here's exactly what we have. Look what we have. We have an x plus 1 raised to the negative 3/4, and we have an x plus 1 raised to the negative 3/4. So it's just like I did over here. What I was able to do is take this exponent and break it up. So therefore, break it up so I have the exact same base and power. Now, ladies and gentlemen, I can factor that out. So when I go ahead and factor that out, what do? We just rewrite it as a product times everything else that is left over. So we say, all right, well, what is left over? So now we have an x, right, which is right there, and plus, what am I doing? Plus a x plus 1 raised to the 4/4, which is really the first power, which again, do we really need to rewrite that in parentheses? No, we can actually get rid of that. So we can get rid of the parentheses. That's going to be x plus x, which is a 2x. So now I can rewrite my answer as a 2x plus 1. And then remember, ladies and gentlemen, when you have a negative power, if you want to rewrite this as a positive power, just put it in the denominator. So therefore, now we're going to have this as a x plus 1 raised to the positive 3/4. And then again, if you want to be able to write this with radicals, or maybe you're taking a test and it actually has a radical in the answer, remember, whatever your denominator is, that's going to be the index of your root, and then 3 was going to be the power. So another example of this answer could be 2x over 1 times divided by the 4th root of x plus 1 cubed. So there you go, ladies and gentlemen. I hope you feel confident now on dealing with factoring with rational powers. And if you're looking for more pre-calculus essentials, then check out the next video.